Creating a sign chart for a rational function. Mr. Adams has kind of been doing that all along. I just haven't been telling you that it's a sign chart. So let's consider the function r of x. Why isn't that? Oh, because it's it's not a color. All right. So let's consider the function r of x. All right, and then r of x is already they've taken the liberty to factor it for us already. So now this is called prime factorization, and I throw out a lot of. Actually, you know what? I don't like the way the textbook has it. Well, let's write it both. Let's write it down so you guys can see what I'm talking about. Plus 3 times the quantity x minus 1. All right, so that's how it's printed in your textbook. And I don't like that. Does anybody know why I don't like the way they've written it that way? Well, for one, that it's not real clear what we have. We have a rational function that the numerator and denominator are in prime factorization. All right? So prime factorization means this. Prime means that you can't factor anymore. So when we talk about a prime number, we're talking about you're just left with the number and 1. You can't find any other factors. So when we say prime factorization of polynomials, what we do is we usually break it down into a series of binomials. Okay? And so when I say prime factorization, that means the denominator can't be factored anymore. We factored till we can't factor any further. But I don't like it written this way because I like to think of it in terms like this. Truthfully, the way the textbook has it written, this should be in brackets so that you know everything is in the denominator. Now, why does that make such a big deal to Mr. Adams? By the way, we should all be in courtesy mode. Why does that such a big deal to Mr. Adams? Why is it? Because I want you guys to know what's in the denominator. Why is it that I want you to know what's in the denominator? Raise your hand if you have a guess. Anyone? Yes? Someone? Yeah. Domain. Yeah. She had her hand up. I was pointing to her, but you're right. Domain. The domain can be restricted when the denominator equals 0. So what does this tell me? Well, what this tells me is, when we talk about the domain, x cannot equal -3 and x cannot equal +1. Because that makes this equal to 0 and it makes this equal to 0. So if either one of these equals 0, then the fraction is undefined. So graphically speaking, I can't let x equal this thing. Now, if that's the case, what do we know about this graphically? These are vertical asymptotes. So graphically, nowhere on the graph can x equal -3. Nowhere on the graph can x equal 1. Okay? So we won't have a point when x equals -3 or when x equals 1. So that's going to be a vertical asymptote. All right, so that's the first thing. What's the next thing? Well, what the textbook wants us to do is it wants us to create a sign chart for a rational function. And we could do this. We want to know when this thing's going to be 0. We want to know when it's going to be undefined. And we want to know when it's going to be positive, and we want to know when it's going to be negative. All right, so what we need to do is figure out what the zeros are. Well, the zeros in this particular function occur when? How do I solve that? What do I do? What do I do here? If I want to solve what values for x makes this equal 0, what do you guys think we should do? I'm going to give you the short answer, and then I want you to think about it, and then I'll show you why. The short answer is I just need to set the numerator equal to 0. Because when the numerator equals 0, it doesn't matter what's on the bottom. Does that make sense? Okay? Now, algebraically, in mathematics, we can't just say things. It's a common sense answer, right? But we have to prove things, too. So to prove that, I could think of this as like 0 over 1, right? Which is still 0. Now what do you see? What is the mathematical thing that you see on the board? Starts with the letter P. When you have one fraction set equal to another fraction, what do we call it? Yes? It's a proportion. So how do we solve proportions? Cross multiply. I'm going to take this stuff, okay, and then I'm going to take this stuff, and I'm going to multiply them and set them equal to each other. So now watch this. I've got 2x plus 1 times 1, which is just 2x plus 1. And then I set it equal to this stuff times 0. What's this stuff times 0? 0. 0. So that's where that comes from. All right, so then what I have here is if I subtract 1 from both sides and divide by 2, don't I get x equals negative 1/2? Okay. Now what do we call that? What are some of the names? What did I just do? And what are the names that we call x equals negative 1/2? Yes? X-intercept. So what this is, we call it the x-intercept. So on the graph, my graph is going to cross the x-axis at negative 1/2. Okay. Another name that we call it is a 0. Now the reason we call it a 0 is because we set the thing equal to 0. What we're saying is that y, this right here is saying y equals 0. When we say r of x equals 0, r of x is a fancy formal way of saying y. We're saying y equals 0. When does y equal 0? At the x-intercept. Now we also call it a solution because solutions are anything that makes the equation true. This is called a solution because when x equals negative 1/2, my function r of x will equal 0. So a solution is any value of x that makes the equation, which is well, it's a logical statement, and so any value that makes that logical statement true is a solution. Sometimes we call this a root because sometimes we have to take the square root of something. Now it isn't the case here. We didn't have to take the square root of anything. So this term, although we normally use it, doesn't necessarily apply. Okay? Now, the chart that they want us to do is we were asked to find the following things. We were asked to find A, when was this thing equal to 0? B, when was this function undefined? C, when was this thing positive? And D, when was this thing negative? And I'm running out of room. When is this thing equal to 0? Well, this is equal to 0 when x equals negative 1/2. When is this thing undefined? What makes the denominator equal 0? Yes?
When the denominator, when x equals negative 3 or x equals 1.
Okay, now this positive negative business we have to do a little differently. Okay, so what I'm going to do is I'm going to close this off here and we'll come back and answer it. This is where we need the sign chart. Now what the sign chart is saying to us is when I graph the function, it crosses the x-axis. So what we need to think in our mind is, I'm going to draw down here. Okay. Now this is a rational function. We know that there's a vertical asymptote at 1 and at -3. Okay. We also know that my function is going to cross the x-axis at what number? Huh? Somebody said it. When is this going to cross the x-axis? It's going to cross the x-axis when x equals -1/2. So right here, it's going to cross. So that tells me anything to the left of -1/2 has the potential to be positive or negative. I don't know. Anything to the right of -1/2 has the potential to be positive or negative. I don't know. So what I need to do is pick out a number greater than -1/2. Now here's the other thing too. Because there are vertical asymptotes, there's a drastic change at where the function is undefined. So we also have to address this issue at -3 and at 1. Because remember, on the rational functions, sometimes we get this funny business where it comes down this way and comes down this way because the function can't cross those vertical asymptotes. So now we know it's only going to cross the x-axis, but we might have like a parabolic shape. We might have something that doesn't cross the x-axis. Right? We might have a horizontal asymptote at 0, which we do. Or no, wait. Maybe we don't. No, we don't. But we're going to have, we'll graph it when we're done and you'll see. So I think probably what this will look like graphically is it'll come down through here and it'll come down through here. Now Mr. Adams only knows this because, well, I've been teaching math a long time and I'm looking at the graph of my book right now. Okay? So I know that that's probably what the graph is going to look like. But how do I prove when it's positive and when it's negative? It's positive whenever we're above the x-axis, right? So anything up here is positive. Anything right above here, that's positive. Okay? And then anything below here, below the x-axis, that's negative. So I want to prove that algebraically. So the only way that I can prove that algebraically is I have to remember that the function why would I just do that? My original function r of x is equal to 2x plus 1 over x plus 3 times the quantity x minus 1. So I'm going to pick a number greater than -3. Pick a really big number, -100. -100 will give me what on the top? A negative. And then on the bottom of what I have? A negative times a negative, which would be positive, right? What is the overall sign for that? Negative. So from here to here, it's negative. Now if we look at the graph, is that true? Yeah. any value less than -3 has a negative y value. So when x is less than -3, we have a negative y value. Well, what about in between? Pick a number between -3 and -1/2, -1. When I plug in a -1 in the top, I get -2 plus 1. So I've got a negative on the top. Then on the bottom, -1, I have a positive times a negative. Now, what is the overall sign of that value? Positive, because these two negatives will cancel out. So that's positive. Well, guess what? That's true. When I pick a value between -1/2 and 1, 0, I get a positive 1 in the top, and then a positive 3 times a -1. So I've got positive times a negative. What's the overall? Negative. That's true. Now when I get any value greater than 1, I'm going to pick a really big number like 100. I'm going to have a positive on the top, a positive and a positive and a positive. Right? So this overall thing is positive, which is true. So when is this thing positive? Well, this thing is positive from wait, let me think about this for a second. This is positive from -3 to 1/2, right? Can we include the 1/2? Yep. So we say from -3 to -1/2, but we can include the 1/2. And then it's positive again from 1 and beyond. Can we include the 1? No, we cannot. So this would be 1, comma, positive infinity. When is it negative? Well, from negative infinity, comma, all the way up to -3, right? We can't include both of them, so then we say union with -1/2 to 1. But we can include -1/2. Well, technically, I take that back. At 1/2, what does it equal? 0. So is 0 positive or negative? It's not positive and it's not negative, so we can't include that. So then over here I can't include that. That was a mistake. So then this goes from -1/2, comma, 1. Okay? Now why did we go through all that work? Well, the reason that we went through all that work is because we might be asked, when is r of x equal to 0? When is r of x greater than 0? When is r of x less than 0? And we can do it with a graphing calculator, but we need to know how to do it algebraically. Does anybody have any questions on that?